Hello, this is Jeff Badge of the Grinding Doc. A super short video to explain why CERMETS are so nasty to grind. Okay, we're not going to get into recommendations of how to grind it. We're not going to get into other stuff. I'm just going to explain the fundamental reasons why CERMETS are so much nastier than tungsten carbide. Okay, so let's take a look at what exactly is a CERMET. Tungsten carbide, also called solid carbide, also called cemented carbide, also called hard metal, is just tungsten carbide, WC, held in a cobalt matrix. Cobalt is a soft metal, and tungsten carbide is really not that hard. At least it's not hard compared to diamond. So when the diamond comes and attacks the tungsten carbide, the diamond wins, and it's just not a big deal. Okay, so tungsten carbide doesn't really dull diamonds. There's some exceptions. If you grind a water-based coolant, you will get some slow dulling. If you're grinding with a plated wheel, you'll get some dulling. But for hardcore material removal in tool grinding, round tools, fluke grinding, and everything else, the diamond grits don't become dull and flat. Now the wheel loads, and that's what's nasty about tungsten carbide grinding. The wheel clogs and loads, but the grits don't become dull. Now, what is CERMET? CERMET is basically the same fundamental concept of tungsten carbide. We have a hard particle that's held in place by a bonding agent. And with tungsten carbide, the bonding agent is cobalt, and then the hard particle is tungsten carbide. With CERMETs, the binding agent might be copper or it might be some other metal, but same thing, it's a soft metal. But CERMETs, what we do is instead of throwing in tungsten carbide, we throw in other stuff. And that other stuff can be a lot of different things. It can be tungsten carbide also, but it can also, you can throw in vanadium carbides and ceramics, aluminum oxide, silicon carbide, other stuff, other hard ceramic materials. And these hard ceramic materials approach the hardness of diamond. They're not quite close there, but they're getting closer to the hardness of diamond. So what happens is they dull the diamond grits. Where tungsten carbide does not dull diamond grits, the aluminum oxide, silicon carbide, and other stuff they throw in there does dull the diamond grits. That's reason number one. Reason number two is CERMETs have poor thermal conductivity. So when you grind them, they don't suck away heat. The heat stays there at the surface. That's not even the biggest reason. We could live with that. We could live with the lower thermal conductivity. But what makes it difficult is when we grind, the grits become dull. So after grinding CERMETs, we get loading also. CERMETs load the wheel, but we can cope with that by sticking the wheel. Easy. We stick it, we clear away the loading, fine. But what's different about CERMETs is it also dulls the grits. And we stick the wheel. You can't remove dull grits from loading by sticking. You can't fracture those diamonds. Some people say you can, you can't. You can bust them out of the bond material, but then you've lost your diamond. But really, we just have dull diamonds. Some years ago, I did a collaboration with Land Super Abrasives and Vollmer in Biberach, Germany. And I went to Biberach and I hung out for a few days and we ground CERMETs. And we measured power and we did other stuff. I'm not going to get into that discussion here. It's given in the book of grinding. But this is a top view of a cup wheel. So we have a cup wheel here. We ground CERMETs, and then we looked at it in an SEM microscope, and we looked down at the wheel. Looking down at the wheel from the top, and here's what we see. What we see is bond material and loading in here, okay? And then what we have here is a nasty flat grit. That's actually probably not a dull grit, but this one right here is. You can see the direction of grinding right here. And what we have is that nasty dull grit. And grinding with a dull grit means a lot of rubbing, means a lot of heat generation, it means huge normal forces, it means cracking of the CERMET possibly if things get hot enough. It just means general unpleasantness, okay? So that's what makes CERMET, that's the biggest factor causing CERMETs to be difficult to grind, is because those little hard particulates in the CERMETs, those little hard ceramic particles, are close, they're not quite there, but they're getting close to the hardness of the diamond. They dull the diamond, so now we have dull, flat grits in our grinding wheel, and we're grinding with a dull, flat grinding wheel, and the only way to fix that really is to true the wheel. Now, in the book of grinding, I talk about how you grind CERMETs and what you do with grit penetration depths and aggressiveness, what you do with grit sizes and grit friabilities. That's another subject. But here, the purpose of this was just to explain why CERMETS are nasty to grind. Carbide loads the wheel, CERMETS load the wheel and dull the wheel, and there's just no way to cope with the dulling. Cope with the loading, you can't cope with the dulling, and it just makes things nasty and unpleasant. Jeff Badger, the Grinding Doc. This is all material pulled from the book of grinding, which you get if you attend my grinding course, and all just fundamentals of grinding that you need to know if you're going to be a good grinder.